Hello and welcome back. It's hard to believe we are already done with 1/3 of the course. One of your classmates suggested in the forum that I welcome you once, or at least once, I guess, in Greek. So, καλώς επιστρέψετε στο μάθημα. This is going to be a fun week. Image and video enhancement is a fun topic. One of the challenging parts of the course is over, and you might say that it'll be smooth sail moving forward. While some topics will be more mathematical than others, most of the topics that will follow are application-driven and probably not as demanding as the material of weeks 2 and 3. Enhancement is a fun topic because we will learn certain tools that we can utilize right away and which will allow us to play in some sense with images and videos. On top of that, we will be the judges of how good and pleasing the enhanced image is. So, based on the tools we learned this week, we can carry out and try your favorite enhancement technique on an image. And if you're not happy with the result, you can change or tune the parameters which control the performance of the technique, or just try another competing enhancement technique altogether until you're satisfied with the results. It's a fun topic because it's very intuitive and rather straightforward to understand, or at least the better part of it. Enhancement is certainly one of those processes that it is used everywhere at all times. You don't like how an image looks? Well, let's enhance it. Actually, all image processing software packages include a good number of enhancement modules in their repertoire. So, during this week, we'll introduce the topics of enhancement and distinguish it from the topic of restoration, which we will cover during weeks 6 and 7. We will then first cover point-wise transformations of the intensity of an image, either based on a general objective, such as stretching the contrast of an image, or by analyzing the image, and more specifically its histogram, imposing an objective on the histogram, such as equalizing it, and then deriving the point-wise transformations of the intensity values. After that, we'll cover transformations of the intensity value of the image based on the properties of the neighborhood of a pixel, performed both by an LSI system that we discussed in weeks 2 and 3, but also by a nonlinear filter. We will then cover techniques which allow the image to look sharper, a specific technique for reducing the dynamic range while at the same time increasing the local contrast of an image through homomorphic filtering, the notion of adding color to a black and white image, and finally some simple notions of enhancing a video sequence. So, let us start this exciting week with an introductory segment where the distinction between image enhancement and recovery is made. We will cover this week image enhancement, while in the following weeks we'll be covering image recovery. It is therefore worthwhile drawing the distinction between these two related topics. With enhancement, the objective is to manipulate or transform an image so that its usefulness or visual appearance is increased. No explicit determination is made of how this increase in usefulness or visual appearance will be measured. With restoration or recovery, we are modeling the degradation the image is subjected to, and our objective is to remove this degradation and therefore recover some of the information that was lost based on an optimality criterion. So there are two important steps that are involved: the modeling and the determination of an optimality criterion based on which this degradation is removed. Let us now look at some examples. The first one is the modification of the intensities values of an image so that the contrast is increased. Since no modeling of the degradation is involved, at least explicitly, and no optimality criterion is determined based on which the contrast will be increased, this is definitely an enhancement approach. The second example is deconvolution. In this problem, the degradation is modeled as the convolution of the original image with the impulse response of the degradation system. So in other words, the degradation system is linear and spatially invariant, as we learned earlier. And the objective is to undo this effect of the degradation system or deconvolve the image based on an optimality criterion. So this is therefore certainly a restoration problem. The third example is in painting. As we'll see, the degradation is, in this case, removes the intensity values of the pixels in a part of the image, and the objective is to estimate these missing values. So if this estimation is done without determining an optimality criterion, just doing an operation that simply makes sense, then we have an enhancement problem. If, on the other hand, the in-painting procedure depends on an optimality criterion, then we have a recovery problem. So this could be either enhancement or recovery. In this class, we'll talk about in-painting as a recovery problem. And the final example is the smoothing or removal of noise in an image. This problem also can be either an enhancement or a restoration problem, depending on whether the noise characteristics are modeled and also whether a specific optimality criterion is defined. We'll cover actually noise smoothing in this class both as an enhancement and as a restoration problem. It should be noted here that this distinction between enhancement and restoration is here to guide our presentation of the various approaches and also to guide our thought process when we're trying to solve an image processing problem. It's not here to somehow erect solid walls between these two topics and somehow penalize somebody if an enhancement technique is called a restoration technique or the other way around. Here is a summary of some of the main characteristics of image enhancement algorithms. There are no theoretical guidelines in approaching an enhancement problem. Each enhancement problem is different, and the criteria for enhancement are typically subjective. We want to increase the visual quality of an image, for example, but each viewer typically has a different quality norm in their mind or in their eyes. Each of us most probably will have a different preference when we are presented with processed versions of an image, and we are asked to find which one has the best quality. These criteria might even be too complex to convert them to useful objective criteria. Because of that, the enhancement algorithms are qualitative and ad hoc. They kind of make sense, and in most cases they work well, but they're also application dependent. A different transformation of the intensities might be performed if a user is to evaluate the image, or if this image is input to an object detection or an object tracking or a classification system. Finally, coupled with the previous comments, the evaluation of the effectiveness of the enhancement algorithm should also be application dependent. Again, if the enhanced image is intended for a human viewer or for a classifier, the criteria for evaluating its effectiveness should differ. So enhancement techniques in general are easy to understand, and they've been very useful and very widely used, and a large number of them are actually implemented in software packages. So we will present a number of techniques next and show examples where after enhancing the image is more pleasing to look at, or it provides additional information to a classifier or an object recognition or object tracking system. We will also see examples where features or objects in an image that were not visible before enhancement are now visible after enhancement. So let us now look at some of these enhancement approaches. The image enhancement topics we'll be covering in this class are point-wise intensity transformations that are defined ahead of time to suit our purposes towards enhancing an image, point-wise intensity transformations that result from objectives we impose on the histogram of the image, spatial filtering, both linear and spatially invariant and nonlinear. We'll see examples for filtering for noise smoothing, sharpening, homomorphic filtering, applications of pseudo-coloring, and some examples on video enhancement. Let us proceed now with the first topic on the list.